Hi, and welcome to Xamarin University, and thank you for joining me today for this recording of IOS240, where we're going to explore touch and gestures in Xamarin iOS. My name is Adrian Stevens, and I'll be your instructor today. And before we get started, please make sure you've downloaded the class materials, and if you haven't done so, pause the video, open up your web browser, and navigate to university.xamarin.com. If you go to the course list, you should see a link to download the course materials for iOS 240. So let's begin. Now, mobile devices are all driven these days through touch interfaces, and almost exclusively. And in fact, the touch paradigm is sweeping through all kinds of devices these days. From cars to mobile, even to appliances. And much of the credit for commercializing touch-based interfaces goes to Apple because, largely due to the success of the iPhone. But it didn't start there. Microsoft spent millions of dollars researching natural user interface paradigms, or what they refer to as NUI design. And we see evidence of touch and stylus systems going back all the way to Palm Pilot, even to the Apple Newton. Now, when the original iPhone was released, it was arguably the first successful high-profile consumer device that was easy to use with just a finger, and as we all know, this wasn't just a convenience. iOS devices don't rely on buttons for interaction, and so a great touchscreen experience is essential. Now we're going to talk about the underlying APIs that drive the touch experience in iOS and see how we can leverage that as developers. So let's take a look at the APIs we can use to respond to touch in our iOS applications. We'll start by seeing what's required to enable touch response to our UI view things, our UI views, and then see how we respond to those touch events. Now, users expect interactive screens, and going back to Microsoft, they even predicted that by 2015, the majority of desktop computers would have touchscreen devices, and it's actually become very true, at least in the Windows market. And touch is a really natural way to interact with your content, and much more so even than a mouse. And think about watching children or even toddlers interact with touch devices. They find the medium easy to grasp. They see a fun object on the screen and they want to touch it, they want to interact with it. Now, we've been trained to understand higher level gestures beyond just tapping things. And for example, a mapping application will likely change the position of the map when you drag your finger, or rotate the map when you twist two fingers in a circular pattern. A book style application will let you flip between the pages by swiping in a left or right direction. And of course, even games. Game characters or elements in these games will likely react to being tapped or dragged. So we're going to focus on a couple of APIs to enable this today. First, we're going to explore responding directly to touch events. And this allows us as developers to add behavior for each phase of a touch interaction. This includes touching the screen, moving a finger while in contact with the screen, and lifting the finger from the screen. Then we're going to use gestures, and these are higher level abstractions, and they're on top of the touch events, and these allow your app to respond to repeatable continuous patterns of touch events. So for example, swiping a screen, rotating, changing the distance between two fingers, or even things like double tapping on an object. Now, in iOS, some UI views have already been designed for touch, and they've been designed specifically to respond to touch interactions. I'm sure you can think of some examples already. Buttons, switches, and even things like our table views are excellent examples. And these controls all utilize the lower level touch events that we're going to talk about to implement this interactive, visually responding behavior. Now, to use these views, often all we need to do is subscribe to an event handler in our application code and then implement the logic to respond to that interaction. And again, an example. we subscribe to the touch up inside event on a UI button when we just want to handle a tap notification. Now this event is actually exposed by the base UI control class, and so you can get the same style of notifications for most controls. But there are times when it's necessary to receive fine-grained information for each part of the interaction, or where you'd like to deal with touch interactions on views which do not extend UI control. Now this is most common with entertainment style applications. So you may need to update state variables in your game logic so it knows exactly when and how you're interacting with in-game elements. And the same is often true with multimedia applications, especially those used to create or edit content, like drawing applications. In order for touch events to be raised and reported for a given UI view, user interaction must be enabled. Now controls enable this by default, as you might expect, but for other views, this can be done in the designer by selecting the view and checking user interaction enabled in the properties pane. This can also be accomplished programmatically by setting the user interaction enabled property to true. Now again, some views have this property set to true by default, but it's generally considered best practice to explicitly set this to true regardless if you are enabling it programmatically. This ensures user interactions are enabled, of course, but also clarifies your intention for other developers when reading your source code. Apple has defined 4 phases of a touch interaction that you can handle. There's began, moved, ended, and canceled. Now the first 3, began, moved, and ended, are fairly obvious, and these correspond to a simple touch interaction where you touch the screen, move your finger, and then lift it from the screen. But canceled is interesting, and it could have alternatively been called interrupted, because canceled occurs when the touch sequence was ended due to some external stimulus. And can you think of anything that might cause a touch sequence to be interrupted? Well, we've got a great example on the screen. An incoming phone call. An incoming text or SMS would do the same thing, or even something as simple as a low power or low memory notification. These touch phases correspond to virtual methods. We have touch as began, which is called when a finger touches the screen. Touch as moved, called repeatedly as a finger moves on screen. And again, touch as ended is called when our finger is lifted from the screen. And finally, of course, we have touch as canceled, and this is called when our touch was interrupted. Now, these methods are defined on a common base class named UIResponder and inherited by all of your views, all of your view controllers, as well as the global UI application object. When a hardware touch event occurs, iOS determines the initial view through hit testing. This is where it compares the coordinates of the touch with each of the frames present on screen. Now the located view is then consulted to see if it wants to handle the touch event. In other words, it has touch as enabled, and it overrides the touch as began method. Now as an example, let's tap on an initial view as we see on screen. Now the initial view attempts to handle the event or message, and if it can't handle the event, it passes the event to its super view. Because the initial view is not the topmost view in its view controller's hierarchy. Now the super view attempts to handle the event, and if it doesn't handle the event, it will pass the event to its super view, again, because it's still not the topmost view. The topmost view now gets a turn to handle the event, and if it doesn't, it will pass the event on to its view controller. The view controller, like the views, will attempt to handle the event, and if it doesn't, it passes the event on to the window. Now, if the window can't handle the event, it will then be passed on to the singleton app object. And finally, if that doesn't handle the event, then the event is simply discarded. Now, this discovery chain allows you to handle touch events at different levels. So directly on a view, on the view controller, on the window, or at the application level. Now it is most common to override the touch methods in the view controller. So let's give this a try in a group exercise. And we're going to override the touch methods. So let's do this exercise together. So please open up your preferred IDE, either Xamarin Studio on your Mac or Visual Studio on the PC. And just a reminder, if you are using the PC, make sure that your build host is running and ready. Let's create a new solution, and we'll make a single view iOS application. And we'll call this Touch Events. And when your project is ready, please open up Main Storyboard. And when your storyboard is loaded, let's add a UI view to the view controller. So search for UI view in the toolbox, and let's drag one onto our view controller. Make this a little bit larger. And right away, let's just set the background color to something visible. And I'm going to choose green. Now, with our view selected, in our Properties pane, I want you to look under View Interaction and notice that we have User Interaction enabled. This means that our view will be able to respond to touch events. Perfect. So I want to add a backing class for our view. So under Identity, let's just give it a class name of MyView. And notice when we do that, it does create the myview.cs in our project. Let's go ahead and open that up. And in our myView class, we can now override our touch methods. So public override touch began. Touch is moved, and we'll do the other two. Now in each of these methods, I'm going to do a console write line. And we'll keep this simple, and let's just use the method name so we know which one has been raised. And let's run our application. And you can run this in the simulator or on a physical device. Now, let's click on our view, and we see touches began. When I let go, touches ended. If I click outside of our view, well, nothing happens. And of course, if I click and I move, well, holding the mouse button down or touching the screen, we see we get a series of touches moved events. Now let's add just a little bit more code. Let's stop our project and open up your viewcontroller.cs. And let's again override touches began. And let's do a console write line. We're going to call this VC, touches began. And our app is running. Let's click outside of our view first, and we see VC touches began. Now let's click inside of our view. And note what happens. We're actually getting both touches began. And the reason for this is we actually haven't given any indication that we don't want that to happen. We haven't really told our application that we only want our touches happening within our view. So go back to myview.cs and notice that we're calling the base implementation of all of our touch overrides. And so we're basically passing that back and saying, hey, we haven't handled that. So if we don't want our touch events to fall through, simply don't call the base implementation. And this will effectively trap the touch event. It stops it here. And so now if I click on our view, it only gets raised within the view bounds for our view. And if I click outside of it, then of course, again, the view controller picks it up. Now let's go a little bit deeper and look at the data that we can receive during our touch events. Now our touch event methods deliver touch data within an NSSet. An NSSet is simply an immutable iOS unordered collection class, and in this case it's used to hold a collection of active touch points, one object per touch being reported by the event. For single touch, we can extract the data using the AnyObject property, and we then cast it to a UITouch object, and this is the object which has the actual touch data and details. Now the UITouch object represents the presence or movement of a finger on screen for a particular event, and the UITouch object contains information about that touch event. Specifically, it provides the location of the touch, when the touch occurred, the number of taps, and the phase of the touch. Again, began, moved, ended, or canceled. And you can see here there are a number of interesting properties and methods. Again, we can see the phase. There's interesting things like the major radius, which can sometimes be used to get an indication of the amount of pressure being used on screen. And again, we see tap count and the timestamp. Now, a method you're very likely to use often is location in view. And it's used to get the current location of the finger from the UITouch object. Now, location in view takes a single UI view parameter, and this is the view object whose coordinate system will be used to determine the location. And you can pass in null to get the location relative to the screen. And you can also retrieve the previous location using the previous location in view method. And if you use these two methods together, this allows you to find the relative movement from the last reported event. Now let's do our first individual exercise where you're going to get a chance to use these methods and you're going to perform some drag and snap movement. It's time now for your first individual exercise. So please open up the Start Here document, and we'll take a moment to review. First, we have our setup requirements, our overview of the class we're doing today, our objectives, and a link to the PDF version of the slides that I'm using to present here today. And don't forget these are here. That's an excellent review tool once the class is completed. And we're going to work on exercise number 1. You're going to get a chance to respond to touch events. We have approximately 20 minutes for this exercise, but of course you can take as long as you like. And you're going to move some UI elements on screen, and depending on where you let go, you're going to implement some behavior. Specifically, we're going to do what we call drag and snap. And so we're going to try and move our Xamarin logo into our boxes. And if you let go within the bounds of the box, we're going to have the logo position itself within the center of those boxes. Otherwise, it will reset to the center of the screen. Now, there is a starter solution in the Part 1 resources folder, and that's so you don't have to go through the setup of creating the initial UI view, but you will do all of the work of working with those touch events. So I'm going to ask you to please start your first individual exercise, exercise number 1. And I'm going to ask you to pause the video and then resume the video when you're ready to review. Okay, let's review our drag and snap exercise. And I've opened the solution in the Start folder. And the first thing we'll do is run the application. And here we see our UI. We've got a couple of boxes and a Xamarin logo. And we'll see there's no touch interactivity yet. And we'll add that. Let's stop the application. Let's open up main storyboard. Now, in order to work with our views, we're going to have to name them in the storyboard. So we'll do that first. So select the Xamarin logo, and in the properties pane, let's give it a name. I'm just going to call this IMG logo. Let's also name our boxes. So I've selected the box on the left, and we'll call this box 1. And the box on the right will become box 2. Now let's go to our drag and snap view controller code behind. And I'm going to add a helper property, a classable variable, bool. And we'll call this image is moving. And this is just going to track state, so we know if we're dragging our logo or not. I'm going to do one other thing as well. I'm just going to make sure that our Xamarin logo is the topmost view relative to the view controller. So I'm going to type in this.view.bring subview to front, and then just give it image logo. And that's just going to make sure it's on the top of the Z order, so it's always visible. We don't want it going behind our boxes. Now, just like we did previously, we're going to respond to our touch event. So let's override touches began. And so we know we don't need to call the base implementation, but it won't do any harm in this case. Now I want to get the touch data, so I'm going to get that from our NSSet, that touches. I'm just going to call touches.anyObject, and then we want this as a UITouch. Now, of course, anytime we're casting, we should always do a null check. And if that fails for any reason, we'll just return, but it shouldn't. Now, because we're calling touches began on the view controller, we want to make sure we only want to move things if we're clicking on our image logo. So we're going to do some bounds checking. So I want to see if we've clicked on the logo. So I can use a method called contains, and that's on our CGRect, on our frame of our logo. And we can get the location of our touch by using the location in view method, as we saw in the slides, on our UITouch. So touch.location in view, and we want that relative to the view controller. So we'll use that view contained in our view controller, we'll say this.view. And if that is true, well, then we've clicked on our logo. So I'm going to set that state bool image is moving to true. And we'll fix my spelling mistake. Excellent. So we know we've clicked on our logo. Now let's move our logo. So to do that, we're going to override touch is moved. And again, let's get a reference to our touch data, our UITouch object, just like we did before, touches.anyObject as UITouch. Now, we'll do a couple of checks here. If image is moving equals false, or again, if our touch object is null, then we don't have any work we want to do, so we're just going to return. So now we've assumed that our touches began was within our logo, and now we've moved our finger on screen. So now we can do some work to actually update the position of our logo. So let's get what we call a delta, which is a term we often see in science or math, just to mean change. Let's see how far we've moved both the x direction, the horizontal, and the vertical, the y. So use an n float, call it delta x, and I can go touch dot our previous location in view, and again we'll use our view controller. And for this case, we actually could just as easily put null here as well, because we're getting a delta, so it's just a change relative to the screen. Either is fine. And we're going to subtract location in view. So the old location, subtract the new location, and it'll be consistent. I'll use null here. It's perfectly valid. And then I'm going to do something very similar for y as well. And just remember to change this to .y. Oh yes, and I have a mistake here. That top one should be .x. So previous location in view x, and location in view x. Previous location in view y, location in view y. So we have our changes in both directions, both vertically and horizontally. So now let's create a new location. So I'm going to make a var called new point. That's going to be a new CG point. And I'm going to base it off the logo's existing position and then update it with the delta, with the change. We'll do that for both directions. Image logo dot frame dot y minus delta y again. Now that we have our new point, we're going to update the position of our logo. And we may need to resolve CG point. Just going to right click resolve, and that's just using core graphics. And so we'll update the frame here. We're going to make a new CGRect. And so the position will be our new point. and the size will be the old size. We won't change that, so we'll use the existing frame size. Okay, so this will actually move our logo on screen, but I want to do just a little bit more work before we run our application. And let's do the work for touches ended now. But if you'd like, go ahead and pause the video and try the application, and you can drag the logo on screen. Let's override touches ended. And just like we did before, let's get our UITouch. And just like we did before, we want to make sure that we're moving and that is not null. So for our drag and snap behavior, we want to see where we're letting go. Where is our touch ending? And more specifically, we want to see if that's within one of our two purple boxes. So just like we did earlier, we're going to do a little bit of hit detection. So we'll use the frame of box 1, and we're going to see if it contains, well, our logo. And more specifically, we're going to see if the center of our logo is within the bounds of the box, and that's going to give us pretty reasonable behavior. And if you think about that, that means if the center of our logo is within the box, it means that at least half of our logo is over top of that box. That feels pretty good. So I can get the center by going image logo dot center, just like that. And we'll be explicit by saying equals true. And so if it is within the box, let's snap it into position. So I'm going to make the center of our logo match the center of that box. So image logo.center equals box1.center. And we'll do a little bit of copy paste coding. We're going to duplicate this, but change it to box 2. We could put an else here as well. Although only one of those will ever be true because the boxes are not overlapping. Now finally, if both of these fail, let's just return our code complete here. Let's just return our logo to the center of the screen. We can get that using the view controller's view. And again, just like using the boxes, image logo.center equals this.view.center. And last but certainly not least, don't forget to update our state boolean image is moving equals false. Now, for completeness, you may also want to put just a little bit of code in here to override touches canceled. Always a good idea, and we'll just keep this simple for now. We'll say image is moving equals false. And you know, you could even return the logo to the center of the screen if you think it's been interrupted. Maybe that's not a bad idea as well. And let's run our application. So first, let's try moving our logo. And you see, we click on the logo and move our finger, the logo moves. If we click outside or anywhere else on the screen, the logo does not move. We have to click on it to move it. And when we let go, it snaps back to the center of the screen. Now, if we let go on top of one of the boxes, we see it snaps into position. And this is great behavior, and this is an excellent way to make game UI or even some business UI. Really nice drag and snap functionality, but we can make it a little bit prettier. And this is beyond what I want to go into right now, but there is an alternate project in the completed folder that adds animations. And so when you let go of the logo, it snaps into place, but actually animates into position. And you can go ahead and explore that code. It's just using UI view animations. Not too difficult and lots of fun to use. Now that we've seen how to respond to touch events, let's take a moment to think about how to present our UI when enabling touch. And one of the most important aspects of touchable UI is making sure that the user knows that areas of the screen are, well, simply put, touchable. And you can use a variety of techniques to indicate touchable UI, and often you'll use more than one. And you can see several common cues listed on screen. If you're coming from a web or a desktop background, designing an app for touch is actually quite a bit different than designing for a mouse and keyboard. And touch is all about content and direct interaction with that content. So consider how the user will interact with the screen and the data on it. Make sure that your UI elements are large enough to easily touch without getting confused with other things on the screen. Remember, some people have large fingers. Now, Apple recommends a touch target size of 44 points, and that's a minimum. And maintain space between elements. Apple doesn't have any strict guidelines on this, but give your UI some breathing room, and when designing for touch, try and keep the UI simple. Also think about how the user will hold the device, and this should influence your design. So consider where related elements are placed, so how much movement is required to interact with related elements on the screen. Always test your screens on a real device so you can see how the interaction works and what is obscured by your hand as you use the app. And for some applications, you may even want to consider left-handed versus right-handed users. Now take a look at this UI example. Now, is this a good UI for a mobile phone? Is this a good UI for touch? Well, of course it's not. This is definitely a desktop UI. And this is going to be cumbersome to use. It's not meant for touch. And although this is an extreme example, it is still a good example. And one of the reasons why Apple has been so successful is they've done a great job at laying out their UI for touch. Use simple images. Give your UI space. Make it obvious what's touchable. And this is really going to help the user experience. It's time for a flash quiz, and we're going to use these questions to test our knowledge. So as I go through the questions, please feel free to pause the video, think about the answers before I reveal them to you. Now, question number 1. You should always leave 44 points of space between your views. Is this true or false? And this is false. Apple suggests a minimum size of 44 points, but again, isn't giving guidance for spacing. 5 to 10 points of space is acceptable, and you sometimes can be less if the controls themselves are larger, but again, the concept here is to give your UI some space, some breathing room. Don't cram your UI too close to each other. What types of cues can you use to indicate interactivity? And yeah, all these are great examples. There are others as well, and don't be afraid to use more than one on the same UI element. And this brings us to the end of our first section. We learned about touch events, we learned how to enable touch interactivity on our UI things, and we saw how to respond to touch events. In our next section, we're going to talk about using more than one finger on screen at the same time, or more specifically, we're going to handle multi-touch events. So first, we're going to ensure our views are able to respond to multiple fingers simultaneously. And then we'll see what code changes are necessary to track multiple fingers across all phases of touch. Now, when might we use this? Well, complex UIs may need to track multiple fingers simultaneously, and this is very common in games and entertainment applications. And the iOS hardware has been designed to respond to multiple fingers. Now, iPhones are capable of tracking 5 touch points, and this is true regardless of which iPhone device you're using. And all iPads, from at least the iPad 2 and up, are capable of tracking 11 fingers. Yes, 11. Now, it is rumored that the underlying hardware is capable of more, but this is what's exposed to us via the APIs. Like earlier, when we discussed enabling touch on our UI views, there's a selection in the designer we need to check to enable multi-touch on our views as well. And this can be done by selecting a view on the design surface and checking multiple touch in the properties pane. And not surprisingly, user interaction enabled also needs to be checked to use multi-touch. Alternatively, multi-touch can be enabled programmatically by setting the multi-touch enable property on a view to true. Now, when using more than one finger simultaneously on a view, our touch event overrides will provide a UITouch object for each finger in that NSSet collection. And you'll likely iterate over each UITouch using something like a for each loop or link to get to that data. Now, for a given touch interaction, the exact same UITouch object will be presented to the event methods for each phase of the touch for a specific finger. And a new object will likely be assigned each time a finger makes contact with the screen. Now, according to Apple documentation, a reference should not be held onto a UITouch object when handling touch events. So, how do we track a UITouch object between events? We know it's the same, but we need some way to identify it. And with that, we'll likely want to associate some type of other data with a specific finger. And so in Xamarin, we can use the handle property. And this is available on all of our managed objects, and it is a unique value that represents the underlying IOS240 object, and this will work across the touch interactions of began, move, ended, or canceled. So for example, here on the slide, we're using the handle as the key in a dictionary to associate a color with each finger. And we could then compare this handle in the touch's move method to retrieve the correct color. And you'll get a chance to try this right now in the next exercise. And so it's time now for exercise number 3, and this one's a lot of fun. You're going to create a multi-touch paint application. So for your second exercise, let's return to the Start Here document. And under exercises, number 2, create a multi-touch paint application. Now this exercise should take you approximately 15 minutes, but like the previous exercise, please pause the video and take as much time as you need. And you're going to create both a multi-touch and a multi-color paint application. And there is a starter solution that has some of the initial setup of the project in UI there for you, let you focus on handling the touch events. And always remember, there are completed solutions included with your exercises if you need to compare your work when you're finished. So please begin exercise number 2. Please pause the video and resume when you're ready to review your work. All right, let's review our XAM draw exercise. So I've gone ahead and opened up the solution in the Start folder. And the first thing I'll do is run the application and see what we're dealing with. And we've got a very plain UI. If I touch the screen, nothing seems to happen, but there is a clear button at the bottom. It doesn't seem to invoke any behavior yet. So let's do the work to do some drawing on screen. So I want to quickly open up the main storyboard. And there's our button, and we also have a UI image view, and it's going to contain our drawing information. It's going to be our drawing surface, and it's just named image draw. Now I won't go into all the complexities of drawing lines, but all the code is here and you can inspect it in more detail later. But we'll take a quick look. So let's go to our XAM draw view controller. And let's look at what code we have here in place already. We have a getRandomColor helper method, and that's just going to return a random UI color. We've done some wiring for the button clear, and that's just going to clear the UI image contained on our UI image view, and then add a brand new one. It's just wiping it out and bringing in a new one. Always important to call dispose on those UI images. And then we've got a little bit of helper code to draw a line. So we can give it 2 points and a color, and it'll go through all the work of drawing lines to our UI image view. And you can take a look at this code in more detail, or you may want to pause the video and inspect it. So what we're going to do is generate a new random color each time a finger touches the screen. And we want to track it during all phases of touch, so we can use that same color to draw as our finger moves. And so this is a perfect use for a dictionary. So we're going to create a dictionary, and we're going to use that handle property of our UITouch objects. And that's actually of type int pointer. And we're going to store iOS colors, UI color. Now let's simply name our dictionary colors, and then we'll new this up right away as well. Int pointer UI color, and don't forget your open and close parentheses to construct it. Now, just like we've had in the previous exercises, let's override touches began. This is where we're going to start. Now, I want to iterate over all of the UI touches that may be contained in the NSSet. And so we'll use a for each loop. And you could absolutely use a link expression here instead. This is a good way to do it. So for each UI touch, and we'll just call that touch locally in touches in our NSSet. So for each touch, let's generate a color. And we're just going to call get random color. And then let's add it to the dictionary. So colors.add. Remember, the key is the handle property. And that's the handle property of our UI touch. So touch.handle, and then add our color. And that's it. And that will work for 1 finger or 11 fingers. And that's going to store a color and with a key that we can track across phases. So let's make use of this. Let's override our touches moved method next. And we don't really need these base implementations either. We can delete them. But again, as we know, they don't do any harm. And so, just like we did previously, we're going to iterate over each UI touch in our NSSet. And we're going to extract the color now from the dictionary based on the handle. So let's make a temporary UI color. And from our dictionary, we're going to call try get value. We're going to pass in the key, touch.handle again. And we're going to ask for the color to come out. And you could even default a color here if you like, just as a failsafe. It should never fail. Maybe we'll go UI color. Dot. Pick a color you like. We'll do black, something that really stands out. We shouldn't have any issue. We know this UI touch event persists across our touch phases, so this hopefully will never happen if we code carefully. So now we have our color. Let's draw our line, and we're going to use that draw line function, method I should say. We need 2 points. Well, we can get that. And we can get that from our UI touch object. So touch dot, remember what it is? Well, let's start with previous location in view. And we'll do it relative to our drawing surface. So we can just go image draw, and then touch dot location in view, and again relative to our drawing surface. Last but not least, of course, is our color. Now we're almost ready to draw, but we don't want to keep adding things to our dictionary, so we should make sure that we remove our values from the dictionary when our finger leaves the screen. Public override, touch is ended, you knew that. Again, we could leave the base call there, we don't need it. And again, we're going to loop through all of our UI touch objects. And we're simply going to remove our color from the dictionary. Colors dot remove touch dot handle. Let's give it a try. Let's run our application again. It looks the same. Let's try touching the screen and moving, and we get a color. If we let go, we get a different color, and you can try a few. Now, if you're using the simulator, you can hold on the Option key, and this will simulate 2 fingers. And we should get 2 lines. But we've forgotten something important. Do you remember what that might be? Let's stop our application, go back to our storyboard. Now, on the view controller, we need to make sure that we have multi-touch enabled. So if we check this and run our application again, we should be able to draw with 2 or more fingers simultaneously. And if you have time, run this on a physical device. With iPhones, you can actually draw 5 lines simultaneously. Or on the iPad, you can grab a friend or use your nose and actually draw 11 lines simultaneously. And our clear button should work here as well. Lots of fun. And there we've created a multi-touch paint application, but almost more importantly, we've proven that our UITouch objects persist across states. So in this section, we saw how to enable multi-touch support on our UI objects and how to properly respond to multi-touch events. And that includes tracking that UITouch object across phases. We now understand how to respond to touch events, and they're really useful for specific types of applications. But what happens when we want to implement more complex touch patterns? So for this, we'll look to a higher level abstraction called a gesture. We've all used motions like pinch and zoom or swipe or rotate to interact with an application. And we could write code to respond to these types of interactions using those touch events we learned about. But it would require a considerable amount of code and probably a lot of debugging and testing. Now, fortunately, Apple has provided APIs to allow us to respond to these more common touch patterns, and again, we refer to these as gestures. So in this next section, we're going to explore the techniques required to add gestures to our applications. So gestures are a continuous series of touch events performed by the user to invoke a specific task. And again, you're probably familiar with many of the common gestures. And so often when using gestures, we're less concerned with the individual phases. And what we really want to know is, what gesture is being performed and has it been completed? And before we go into the mechanics of working with gestures, I wanted to talk a little bit more about the theory of gestures. And in iOS, we have 2 types. The first are discrete gestures, and these are gestures that have a fixed path. And when that path has been followed, the gesture is considered complete. And if the path is deviated beyond a specific threshold, then the gesture will need to be restarted and is considered to have failed. Alternatively, we have continuous gestures, and these have no fixed endpoint. So think about rotation, or pan, or pinch. These gestures are continuous. So really, as long as the user is in contact with the screen and moving the appropriate number of fingers, these gestures can be performed basically indefinitely, or till the user's hand gets tired or the battery runs out. So with that in mind, let's look at the gestures available in the iOS APIs. So we're going to work with the UIGestureRecognizer class to recognize these higher level touch patterns. And the iOS APIs include 6 classes to recognize 6 different gestures. We have UITouchGestureRecognizer, and this is to respond to one or more taps, like a single tap or a double tap. We have the UISwipeGestureRecognizer, and this is so we can respond to swiping in any direction. UILongPressGestureRecognizer is for press and hold, or sometimes referred to as a long press or a long click. And then we have the continuous gestures. So there's UIPinchGestureRecognizer, and this is for pinching and spreading apart fingers, and very often associated with zooming or scaling. We have the UIPanGestureRecognizer, and this is for panning or dragging. And we have the UIRotationGestureRecognizer, and this is when a user rotates 2 fingers in a clockwise or counterclockwise motion, and again, very often is used to rotate an object on screen. So let's walk through the steps required to add and use a gesture within an application. So first, we need to ensure the user interaction has been enabled on our view or view controller, or maybe even the window. And you're more than likely going to want to make sure that you have multi-touch enabled as well if you're planning on using a 2-finger gesture, again like rotation or pinch and zoom. Next, we'll instantiate an instance of the Gesture Recognizer class that you wish to use. And you can see on slide, we're going to use the UITouch gesture recognizer in this code block. Now, some gesture recognizers have additional properties that can be set to modify the behavior, and this is an excellent example. For our tap gesture recognizer, it has a number of taps property, and this is going to control the number of taps required before the gesture has been considered complete. Next, you'll set the target. And the target is the code that will be executed when the gesture has been performed. And this can be done using the addTarget method. Now, there is an alternate approach. The target can also be passed in via the constructor when the gesture recognizer is instantiated. Now, in order for the gesture recognizer to receive the touch data it needs to detect the gesture, it must be added to a view. And all UIView-derived objects have an addGestureRecognizer method. And finally, add code to your target method to respond to the gesture. So let's try this out in an exercise, and you're going to get a chance to work with the PanGestureRecognizer. So please return to your Start Here document, and under Exercises, use a gesture recognizer, click the exercise link. Now, exercise number 3 should take approximately 15 minutes, but of course you're going to pause the video again so you can take as much time as you need. And like our other projects, there is a start solution in the Part 3 resources folder. And of course, we have a completed solution as well that you can use to check your work once you're done. So please pause the video and begin exercise number 3, and of course resume when you're ready to review. Great. Let's take a look at our third exercise. Now, I've opened up the starter solution in the Part 3 resources folder, and the first thing I want to do is run the application. We'll take a look at the UI that's been provided in the start solution. And here we see a Xamarin logo, and if I try touching or interacting with the screen, there's no perceivable behavior, so it doesn't seem to be responding to touch interactions. I'm going to just look quickly at the main storyboard, and we see our design surface, and we see we have a UI image view added to our view controller, but I want to show you that we've given it a name. That's IMG logo, and this will allow us to interact with it from our gestures view controller CS file. So now let's add some code so we can interact with our Xamarin logo. And the first thing we'll do is create a class level variable of type CGPoint. We'll call this translate, and we'll use this as a state variable to track the location or the change in position of our Xamarin logo. Now, the next thing I want to do is write some code to actually update its position. And now we're not working on the gesture just yet, but we're going to have a helper method, and we'll call this update transform. Now, in this method, we're going to create a new transform, and we'll use the CGAffine transform factory method called makeIdentity. This is going to give us a transform. This allows us to apply visual transformations to our UI view things. And we're going to use this to update our image logo's position based on that CG point we just created. So on our new transform, we're going to call the translate method, and we're going to pass in the X and Y positions from our CG point. So let's go translate.x and translate.y. Now finally, to update the logo's position, we set its transform property, and we'll just set that to our local transform variable. So now we'll create a PanGestureRecognizer, and we'll do this in our viewDidLoad method. And so let's make a local PanGestureRecognizer, and we'll call it PanGesture. And we'll make a new UI PanGestureRecognizer. Now remember, we have the option of passing in an action. And we're actually going to use the second overload here, where we're going to set an action that will receive a UI PanGestureRecognizer. And what that means is that our method, our action, that's going to get raised when our gesture is being performed will actually pass in a reference to the gesture recognizer. And this is going to allow us to get some additional information from the recognizer directly. So for now, let's just call our method handlePan. We haven't created it yet. We will in just a moment. And now we need to add the gesture recognizer to a view. And we could add it directly to our image view, and that would work perfectly well, but we're going to add it to the view controller just to make it a little bit easier to test our touch interactions. And we're going to do it this way for our other gesture recognizers that we're going to use in our fourth exercise. So add it to the view on the view controller, this.view, and then we're going to use the add gesture recognizer method, and of course just pass it the pan gesture. So now we'll create our handlePan method. This will just be a void method, and it's going to take a UIPan gesture recognizer as a parameter, which we'll call gesture. Now I want to do just a little bit of setup. When our gesture first starts, I want to sync the recognizer's translation with the view. And so we'll do this every time our gesture is started, and I'm going to do that by checking the gesture state. And when the state is in began, we're going to just update the gesture's translation by calling the set translation method. We'll give that a CG point. That'll be our translate CG point we created earlier. And it's going to be relative to the view on our view controller. And this just means that our image view is not going to jump to our finger's position, but it's going to change its position as we move our finger. It'll just give it us a relative change instead of an absolute XY coordinate. So now let's read the translation from the gesture recognizer. So we'll make a local variable called pos for position. And we can find the gesture's translation within the view by calling the translation in view method, and of course giving it the view that we're using for a relative coordinate system, and that again will be our view controller. Now we'll simply save that off. So we'll set our translate to that local position. Now to actually update our image view, we're going to call the update transform method. And that was the method we created earlier. Remember, that's going to now use our translate CG point to create a new transform, which will effectively change the visuals or the updated position of our image logo. So let's try it out. Let's run our application. So we'll click on our image view, and we see its position updates. But of course, we have put the gesture recognizer on the view controller, so we can click anywhere on our surface to move our Xamarin logo. When working with discrete gestures, you'll likely want to pay attention to the gesture state. So gestures transition through a set of known states, and the gesture recognizer will notify its target as this happens, allowing you to add behavior in response to state changes. So our default state is possible, and it will remain in this state until the user performs an action. Now the state will change to failed if the action doesn't match the gesture pattern. And this is where the recognizer determines that it's definitely not the right gesture for, it's not matching what it's looking for. Or it may transition to recognize if the gesture pattern has been matched correctly and it satisfies the gesture recognizer. So at a minimum, you'll want to check for the recognized state and execute the appropriate code when the gesture has been successfully performed. And once a gesture has been recognized or failed, it will then reset to the possible state once the user removes their fingers from the screen. As just shown, the gesture recognizer runs a state machine as it progresses through the detected states. And we're going to look at an alternate state machine for continuous gestures. And you notice there's a few additional states. But again, it starts in the possible state, and once the user begins, it will change to the begin state. And as the user continues to interact with the screen, the target will be notified and the state will remain at change, and this gives us an opportunity to update the UI based on position or gesture specific values as the continuous gesture is being performed. Now, to detect the states is actually quite easy. You're going to compare the state property of the gesture recognizer object that's passed into that target. There are some additional considerations when using more than one gesture recognizer on the same object. You can combine gestures together, however, iOS does not allow them to run simultaneously by default. Now you can change this by hooking the gesture recognizer's should recognize simultaneously event. Now to enable the gestures to run simultaneously, you can return true or even add additional logic to make decisions based on the gesture being performed and or your application state. And before we move on to that final exercise, I want to ask you a question. Can you think of an example of an application that supports multiple gestures but doesn't allow them to be performed simultaneously? Well, how about the iOS mapping application? You can do things like zoom or rotate or pan, but it doesn't actually allow you to do all these things at the same time. Once a gesture has been started, only that gesture is performed, and that does make sense for that particular application. And so you want to think about whether it makes sense to you and your app to allow gestures to work at the same time. And you can perform specific logic to enable specific gestures to work together or not. And with that, let's go on to our final exercise. We're going to get a chance to use 3 gestures at the same time, and you're going to add scale and rotation to the previous exercise. Let's return to our Start Here document, and under Exercises, exercise number 4, use multiple gestures simultaneously. And this exercise should take approximately 15 minutes, and it's a continuation of the previous exercise where you implemented the pan gesture recognizer. And in this exercise, you're going to add 2 more gesture recognizers and as well add code to make them operate simultaneously. So please pause the video now, start exercise number 4, and as you have done previously, resume the video when you're ready to review. Now I've opened the project that I completed in the previous exercise, and you're welcome to carry on from your existing project from exercise number 3, or optionally use the completed solution in the part 3 resources folder. And we're going to follow very similar steps to our last exercise. We'll start by adding some class level variables to track our other states. Now we're going to add the ability to change the scale of our logo. We're going to zoom in and out, as well as the rotation. So let's add some end floats to track both of those things. And we'll call one rotation. And I'm going to initialize this to 0. We're going to assume that it's at our default, our rotation or default value. So we'll say that's 0. And we'll also add an end float for scale. And we're not going to initialize this to 0. We're going to initialize it to 1, which is going to represent 100%. Now next, let's update our update transform method. And that was where we changed the translation, or the position of our logo. And we're going to add in some code here to set both the scale and the rotation. And it's very similar to what you saw previously. Now, there's something to be aware of here with transformations, and that is that the order that you apply transformation counts. And so we're going to apply the rotation first. We wanted the translation last. So we'll use our CGFE transform, and we're going to use the rotate method. And of course, we're going to pass in that class level variable we just created called rotation. And let's do the same for our scale. There's a method called scale. And it takes a value for both x and y. And we're going to scale both equally in this case. So we'll set both of these to scale. And now with our update transform method complete, we can start adding our new gesture recognizers. And we'll do this again in the viewDidLoad method. Let's start with rotation. We'll call it rotation gesture. And just like before, we're going to new up a rotation gesture recognizer. And let's give it a method, a named method. We'll follow our earlier pattern and call this handle rotation. And right away, we'll add this to the view controller's view. And we'll do the exact same thing with a pinch gesture recognizer. So pinch gesture, new UI pinch gesture recognizer. We'll call this one handle pinch. And this.view.add gesture recognizer pinch gesture. Now let's create those handle methods. Let's start with rotation. Again, it's a void method like we saw in exercise number 3. We'll call this handle rotation. And we're going to accept a rotation gesture recognizer. And we'll simply call this gesture. Now rotation is actually quite simple. We're just going to save off the rotation from the gesture, and our UI rotation gesture recognizer has a rotation property. So we use our class level rotation and float variable, and just set that to the rotation property. Now to update the rotation of our Xamarin logo, we're going to simply call update transform, which will then apply the rotation to our UI image view. Now we'll do the same for handle pinch. Now this time it will of course take a UI pinch gesture recognizer, but we'll call it gesture again for simplicity. Now pinch is a little bit different because we don't want to use the absolute scale or pinch value from the gesture. What we want to know is the difference in scale from the last time it was reported, and then apply that difference in scale to our image logo. So let me give you an example. Let's start our pinch gesture. Maybe we're zooming in, or we're moving our fingers apart. And let's say we've scaled our image logo to double its size. Now we let go, we start our gesture again. We don't want our image logo size to reset to any sort of position. We want it to stay at 200%, but then grow or shrink based on the input from our user. So we want a relative difference. So for that, we're going to use our class level scale property, and we're not going to set it. We're going to multiply by the gesture's scale property. I'm also going to add just a little bit of code to constrain the scale. We don't want it getting too big or too small. And these values are fairly arbitrary, so you can adjust these as you see fit. But I'm going to make it not go any larger than 250%. And I don't want it any smaller than 1%. We'll make it 10% actually, a little more reasonable. Now we're going to do one other thing before we update our visuals. I want to reset the scale of our gesture. So I want our gesture to always be relative to 1. And so what this means is then the next time our gesture recognizer reports the scale, it'll be the difference from 100% or from 1. So if we're moving our fingers outwards, it might get a little bit larger, inwards a little bit smaller, but it'll always be relative to 1, and that means that our math here is going to work out very nicely. And if that doesn't feel quite right, please feel free to pause the video and experiment with it. Turn off, comment out what's line 54 on my screen, see how it behaves. And a little bit of experimentation with these values and this behavior hopefully will clarify the concepts if it's not cemented just yet. Now, just like our other handle methods, we're going to call update transform, remembering of course that we've already added in the code to update the scale earlier on. So let's try out our app now with our 2 new gesture recognizers. We can still move our logo, but now if I hold down the Option key on our simulator, I can do a pinch and zoom. We see it scales nicely, and as I said, it's always a relative change now, so it feels nice and smooth. I can also do rotation. Now what you'll notice though is I can't do pinch and zoom and rotation at the same time, and of course I can't do my panning as well because that's a single finger gesture. But if we wanted to enable these gestures to happen simultaneously, we could add in a little bit of code for that. So let's do that now. So to take control over whether gestures can perform simultaneously, we're going to use a property on our gesture recognizers called should recognize simultaneously. So let's start with rotation. Rotation gesture. And it should recognize simultaneously. And again, we're going to pass this off to a method. And we'll just call this should recognize simultaneously. And we'll do the same thing for our other two gesture recognizers as well. Do a little bit of copy paste. And let's use our pinch gesture and our pan gesture. And so what's going to happen now is if more than one gesture is attempting to be performed at the same time, it's going to execute this should recognize simultaneously delegate. It's going to get executed, and it's expecting a Boolean result, true or false. And that's going to let us know whether we should or should not allow the second gesture to be performed. And if you look at the delegate info, you can see here that the delegate accepts two UI gesture recognizers. The first one will be the first recognizer that is already actively being used, and the second one that is trying to be used. And so you can do some comparisons on those input parameters to decide if you do or do not want them both to be performed simultaneously. So let's implement the method, and then we'll do a nice simple implementation of it. So it's a Boolean method. I'm going to do a copy paste so my names match. Perfect. Should recognize simultaneously. And it takes two UI gesture recognizers. Now these are of course the base class. It's not a specific implementation, but we can do comparison to see what type of gesture recognizer it is. And we'll call that one gesture recognizer, and then we'll do a second UI gesture recognizer, and we'll call this other gesture recognizer. And hopefully this is starting to take some shape now. So we could do comparisons. We could see what type of specific gesture recognizer this is, and of course for the other one as well. And we could do some branching logic and decide, hey, do we want to have rotation and scale at the same time? Maybe we do, maybe we don't. For simplicity, we're just going to return true here. So we're always going to allow them to happen at the same time. And so now if we run our application again, we should see that we're able to scale and rotate at the same time. Again, I'll hold down the Option key. Let's do a rotation, and we can see that it makes it bigger and smaller while we rotate. So pretty powerful, pretty interesting. Of course, relatively straightforward to add 3 gestures to our view controller. So we had a great look at gestures, and we saw how to create a gesture recognizer and assign it to a view. We saw how to respond to a gesture's change in state via the state machine, and we saw that the state machine is different for both discrete and continuous gestures. And we also saw how we can use multiple gestures simultaneously, and even considered that we might not always want to do so. And this brings us to the end of IOS240 Touch in iOS. Thank you very much for joining me for this video presentation today. And remember that you can always get additional information from the excellent documentation provided at developer.xamarin.com. You have access to a dedicated forum if you have specific questions about any of the Xamarin University courses, and you can schedule one-on-one time with an instructor if you need to go deeper on any course materials here at Xamarin University. Thank you again for watching this video, and I hope to see you in a live class very soon.